a welcome to those joining online now. Looking forward to Christmas, but also looking forward to this last 1 hour of the 2022 webinar year. Right, it is officially 2 o'clock here in the UK, and it is other times elsewhere in the world. So welcome everyone to the final TMS Tuesday webinar for 2022. The team we have for today comprises Tony Smith, world-renowned inventor of the PAPI and expert on all things visual aids, bringing to us a lifetime's experience, knowledge and understanding. But similarly, Keith Costall, leading ICAO trainer around the world, trained many of you on this webinar today, I know. Not a day goes by, it seems, when I'm talking to someone and they say they were trained by you, Keith. So it's all your fault. And likewise, Seward in North America. Seward has worked in airfield lighting for a lifetime and has been a AAAE trainer doing the ACE airfield lighting training course for many years, and along with Dave Rainey and now with Brian Fountain and Carl. So we welcome you all today for our final TMS Tuesday webinar. We've got a lot to cover, so we'll try and make it fun for you. We've got a quiz later on. So on today's webinar, we'll be covering a bit of a recap of the highlights from 2022, going over the sessions, the subjects we discussed, talking about some of the key points and chatting about them. As usual, if you have a question, if you have any questions, please use the question and answer box on your screen. Please type them in. We don't have time to take them verbally, but at the end of the session we will answer as many questions as we can in the time allotted, and then we will we will post those answers online, and we'll answer any other questions you may have as well. You can ask questions through this webinar, but at any time you like, to any of the participants, any of the panel. Having looked back at last year, Keith will just be giving us a run through the ever-evolving AGL competency requirements and how to maintain compliance, particularly looking at the standards relating to training and development. Then we're having a quick look at the key developments looking forward into 2023. Give you a taste of what's coming next. We have a prize quiz determined this year that we're going to give 100. Whoever wins the quiz this year, this online quiz, we'll give £100 to the charity of your choice, wherever it might be in the world. Just recognizing there's a lot of people, we're living through very tough times, as I think you all know, and we need to give to those less, those needy people. So whoever wins the quiz, please nominate your charity and we'll donate £100 to it. And then we'll just be talking briefly about what's coming in next month's TMS Tuesday webinar. So and then we'll do questions and answers. So without any further ado, looking back at 2022, these were the webinars we actually presented, and I'll just, rather than read them all out for you, let's just cover each one of them. First of all, the origins of standards and recommended practices. So no, the first one we actually did was runway to recovery. And in runway to recovery, we covered the situation with COVID at the beginning of 2022 and the forecast. Now, I've been looking online at the materials for what's happened in the year and what's happened since 2020, really, when COVID really hit us. You can see here a chart showing the growth in passengers from post-war until COVID hit in 2020, and then what's happened since then. If we could just look at that chart, you'll see that we had an oil crisis in in 1973. Let me just go back. We had an oil crisis in 1973. Then we had the Iran-Iraq war in the early 80s, followed by the Gulf crisis. We had the first pandemic in the 90s, followed by the 9/11 terrorist attack, SARS virus, and of course the 2008 financial crisis, all of which had an impact on air traffic levels, as you can see. But generally, the trend has continued to increase strongly. But nothing has impacted like the COVID virus in 2020, where passenger traffic effectively collapsed to nothing overnight, and we were sustained with cargo traffic, of course. But since then, in this year, we've seen traffic levels start to recover. In 2020 versus 2019, passenger levels were down 60%. We were 49% down on 2019 and 21, so some slight recovery. But we've seen quite a good recovery in 2022, where we're now 30% in terms of passenger levels down on previous years. Looking at the trends, again, we're seeing much stronger recovery in leisure passengers than in business traffic. That's universal. We're seeing the slowest recovery in Southeast Asia, where, of course, in particular, China have been very, very strict with their COVID limitations on travel and the like, and zero tolerance policy until very recently of when an outbreak of COVID occurs. So we've had a very, very tough time, and the outlook is continue. I have to say, I looked at probably a 50-page presentation from ICAO, and it's clear that there are a number of, they're still looking at a number of alternate scenarios. We cannot be sure what is going to be coming down at us. But personally, I don't think we're going to see the limitations on air traffic that we've seen in the past, because frankly, the world can't afford to carry on like that any longer. So moving on then, that was the first thing we talked about, runway to recovery. Now we're looking at the runway lighting management. We talked about how we manage runway lighting. We did a couple of sessions on this in the year, looking at the principles of how we measure. We take the measurements, and you'll hear this message over and over throughout the presentation today. You cannot manage what you do not measure, and that applies to airfield lighting, to COVID, to absolutely everything in life, I believe. So we first of all measure. We take the measurements, have the metrics, and then based on the results of those measurements, then we determine where, when, and what maintenance is actually required. And then we monitor that maintenance to record, the results, what happened, where it happened, what the results were. And then using that information together with the measurement data, we then monitor the performance to ensure compliance. And then all of that information is then aggregated through a central CMMS database to actually manage those assets, that the performance of that environment. In this case, we're talking about visual aids going forward. And that management, now we're looking towards predictive, planned, preventative maintenance based on the results that we've measured in the performance of our duties, so that we can anticipate how often we need to clean our runway, according to the season of the year, according to the weather and the environmental conditions. We know when we need to relamp the lights, when to replace the domes on those elevated edge fittings, because we know when the pitting is going to prevent them becoming compliant. And so all of this information helps us to manage our airside environment, more visual aids, our critical safety visual aids more effectively so that we can deliver safety and compliance whilst at the same time managing our airfields efficiently, cost effectively, and minimizing the interruption to air traffic. Moving on from that, we had a wonderful presentation from Tony, and I won't even begin to try and emulate your words, Tony. Please tell us, summarize where we are on PAPI, please.
Yeah, well, those that were there for the presentation, quite a long one. One of the subjects that is in the background and is an ongoing thing is actually the calculations that are done for location of PAPI to optimize their use. That's a subject on its own. We won't go there today. That's an ongoing thing. The things I wanted to stress were the 1, 2, 3 here, particularly. PAPI relies on 4 projectors having a sharp transition between the 2 signal colors, the red and the white, so sharp enough so that in practice, when you're flying, it looks instantaneous. It looks like the blink of an eye. It relies on that characteristic, and where that is being the setting angle for that unit. 4 different setting angles. They all need to be set with some considerable precision. ICAO specifies this, and it also talks about the transition. Now, just say about the transition, 3 minutes of arc is often quoted. That is the absolute maximum. From my experience, our prototype equipment, which used very basic optics, we managed anything between 1 and 1.5 minutes of arc quite readily. It isn't difficult to achieve. Soft transitions take away a lot of the benefit of PAPI. When we put the PAPI equipment into the world, as it were, for pilots for comment, they liked it over VARs and other systems because the angles were very accurately maintained. They knew where they were and they knew when things changed. It's a digital system. You've got five states and you go from one to other instantaneously. That's important. Number 1, maintaining those. The second is the intensity. That obviously determines the range at which the equipment can be sensibly used in various conditions. The intensity ratio, I think I've discovered in recent discoveries and looking at some equipment, I think there's a misunderstanding, perhaps particularly amongst optical engineers and lighting engineers, the idea that, well, now we've got LED, we can match the red and the white intensities. So it seems an anomaly to have them different. Of course, initially that's how it was with the tungsten filament and with a filter lens, a filter in the system. You've got differences of typically 6 to 1. And we realized when we did the analysis that in a sense, that large change of intensity is just as much an attention getting thing as the color change. And in fact, if the viewing conditions are such that color is a little bit degraded because of a lot of air light, it becomes a bit off perfect. You still got the intensity change. So those people that are pushing towards a 1-to-1 ratio for the intensity are actually taking away some of the key parameters of the PAPI system. It's important to go as near as possible. I would say at least a 5 to 1. Then it's very clear. It's like something being switched on and off as a light, which is what is happening. That intensity change is clearly seen. And the third is the color. The color of red and white are very important that they're maintained. The colors that are emitted are those specified in Annex 14 for those 2 colors. And of course, with the introduction of LED, we do have the benefit of when we turn the intensity down for night operations, the white doesn't tend towards a yellowy or orange color. We should be maintaining almost the same color coordinates as we do at 100%. So there's a benefit there, but that needs to be monitored and checked. And once the equipment is installed, then there needs to be ongoing monitoring, because things move, things fail. You need means of doing testing in service. It's one of my bête noirs, that for many years maintenance people weren't given any sort of indication of what constituted satisfactory monitoring. Well, with PAPI, you can say you need to be able to measure those first three things I mentioned accurately, repeatedly, and as often as necessary. And you need to know there and then whether you've got a pass or a fail. And there's a whole lot of discussion there about what constitutes a suitable measuring system. What I would say is that it's important that it really does do what it's supposed to do, and that it's practicable and you can use it. Then the data you gather from all of this good work needs to be stored for diagnostic work, maintenance processes, and to show your inspectors your compliance records. And in the event of, if unfortunately you have an accident, you can show that your equipment was compliant. I'll stop there because I could go on for a long time, but we've got a lot to do.
Thank you, Tony. Yes, and so I'm sure we'll have a lot more questions there, and this is a topic we'll come back to. Just as you mentioned, Tony, in measuring these throughout the year, we do see two things that surprise me. Is a number of times when we see failure, a lot of PAPIs are still managed on the basis that they only replace lamps on failure. On incandescent light sources, that isn't good enough. They fail effectively long before they go out, if you know what I mean. And the second thing is, when they fail, please replace all the lamps, not just the one that failed, because one failing is an indicator of them all failing. But ideally, you photometrically test them as part of your PAPI testing, and then you can replace. Then you can make sure that the transition is correct, the transition is sharp, the beam is focused, and the color is red and the color is white, and the intensity is where it should be.
Can I just say one more thing,
yes.
Robert, about PAPI? In one sense, the name gives it away. It's a precision instrument. It projects this red-white transition as a set and calibrated angle. That's what the manufacturer has to sell to you. And if when you do your checking, things seem to be somehow out of alignment, out of kilter, and it's not obvious what it is, the last thing you would do, I literally say, on pain of death, don't go taking it apart in the middle of a field. It needs to go back to the manufacturer for maintenance and recalibration. The thing I would liken it to is a theodolite, which I'm sure we're all familiar with. You wouldn't, if you had some concerns about your theodolite, you wouldn't start taking it apart and readjusting where the lens is, or putting the shims under the this, that, and the other. You'd go back to the manufacturer and say that your equipment needs servicing and recalibrating, and that's what you should do. Don't try and make PAPI comply with the in-field measurements by doing in-field maintenance.
Thank you. Yeah, very, very, very important point. Moving on then to, he says, I'm just moving my slide. Yep. Moving on to the next TMS Tuesday, we talked about signs. Signs, as you know, must be conspicuous, legible, comprehensible, and credible. When measuring signs, we do that typically as part of commissioning new signs, but also evaluating older signs to see if they're still compliant. Thing to note about signs is there's no, unlike airfield lighting, there's no 50% serviceability level. It's either they either pass or they fail based on the standards that are out there. And the standards is for the background illuminance of the sign. So the mandatory signs are red, and the information signs are yellow. The background illuminance for a yellow sign should be an average 150 candela for an airport that has low visibility operates in conditions below 800 meters runway visual range, and the mandatory signs 30 candela. Then the characters have to be illuminated, the white to 300 candela, the yellow to 150 candela, and the red again to 30 candela. Now it's very important, those standards are very important so that the sign is conspicuous, legible, comprehensible, and credible in low visibility conditions. And that is the task, to maintain those levels. So clearly, if they don't achieve those levels when they're new, then that needs to be addressed up front. So it's very important that that is absolutely checked. But then in life, maintain them at that level. There are a number of factors that need to be considered. The halogen or other incandescent, the fluorescent tubes and other means of illuminating them typically struggle to meet the standards. The LED signs are much better in my measurement experience, but the halogen lights must be measured and maintained to achieve the standards, regardless of how old they are. So that involves keeping them clean inside and outside, keeping the vegetation down, because there are many signs. And by the way, PAPIs I've seen with long grass growing in front of them that impact on their conspicuity. And then the actual face of the sign needs to be of a condition to actually allow the light to pass through it. And I've seen many signs that are so heavily weathered that they completely block out the light and render the sign ineffective. So really important that sign maintenance. But again, you can't manage what you don't measure. How often do you need to clean a sign or to do maintenance on a sign? Well, it depends on the condition of the sign. You need to do the measurement. A new LED sign will require far less maintenance than an old fluorescent tube sign, and it also depends where it is. If it's been battered by the seas and the sand and the sun, it's probably going to be much worse than if it's in a more temperate, gentle environment. So measurement is absolutely key again there.
One of the things, Robert, that I would interact there is,
yes,
which I mentioned earlier when we were having a brief discussion, is to ensure, of course, when you're looking at the design and the installation of those signs, these are big units. They are elevated units. They are suspect to jet blast, etc. And therefore the structural integrity of the signs, including the bases and the delethalization of the bases that we put the signs on, is also a very important factor to consider.
Absolutely. Thank you for bringing that up. Also, another point, all these topics we're talking about are on the tmstrainingsolutions.com website. We've got recordings of every webinar and all of the slides on the tmstrainingsolutions.com website, so you can view the subject in detail at your leisure, whatever your time zone, and they will be left there for the foreseeable future. So please refer to them if you have any specific questions, or at any time want to refresh your knowledge and understanding, or share them with your colleagues, of course. The next presentation we did was looking at condition-based and performance-based maintenance. And what we're talking about here is moving from a maintenance strategy where we looked at the condition of the assets and then performed the maintenance based on what we found. It's actually continuous process of measurement to be able to plan our maintenance activities in anticipation of future deterioration, wear and tear, and use of the particular asset to optimize their performance, optimize their compliance, and to maximize the efficiency of our maintenance cost and efficiency of our maintenance operations whilst maintaining safety and compliance, of course. So this is all about real-time monitoring, giving ourselves the information to allow the maintenance time to plan their work ahead to ensure that performance levels do not fall below a level where assets will become non-compliant. Again, you cannot manage what you do not measure. After we talked about that, we looked at CMMS systems, which are integral to this process. An airside CMMS system, such as Marm's Engineer, is used to plan and control the maintenance of an airport. All your preventative maintenance actions will sit on the CMMS. Management will have visibility to the performance of those planned preventative maintenance actions, to the performance of and that includes the inspections, torque checking, light cleaning, photometric checking, civils, checking the civils of the runways and the taxiways, recording any faults, looking at installation resistance levels and recording them over time. And all of this information is plotted or mapped and presented in a structured way to allow the user of that information to optimize the efficiency of that asset in such a way that it's looked after not just cost effectively, but safely and in compliance with standards. Also, a CMMS will allow you to maintain records to show, as is required under all standards, national and international, will allow you to show what work was done, when it was done, what the results were, to demonstrate to the regulators and to other stakeholders such as airlines and other airport users that the airport is operating safely and in compliance with standards. Following on from that, we had a TMS Tuesday where Paul Fraser-Benison presented the work that I think he'd been very much initiated with the UK CAA, where he worked on IR/VR and runway lighting. You will recall, hopefully, that IR/VR calculation is dependent on the lighting levels of your runway being at least the level that is specified in your disseminator in your IR/VR system, such that the runway visual range information presented to every pilot taking off and landing is not understated. So that's very, very important. It's critical for safety to land, so the pilot knows what the visibility is going to be for takeoff and landing according to the planes and the conditions in which he's operating. Good IR/VR, accurate IR/VR reporting will improve airport safety, of course, which is a critical factor. It will mean that in reduced visibility conditions, the pilots have accurate IR/VR readings. It results in less diversions or go-arounds. By improving the IR/VR of the airport through maintaining your lights to the highest standard will mean that the early onset of LVPs will be delayed, and going into low visibility procedures themselves will be delayed, and you will come out of low visibility also faster because of the performance of the lighting. Because less planes are left holding unnecessarily because of the increased distances between planes in low visibility conditions, CO2 emissions will be reduced, which of course is very important for the environment. And of course, the airport will be recognized by stakeholders and including the Civil Aviation Authority for their efforts in raising standards and enable them to gain an operational advantage. So again, this is all available. This presentation from Paul is available on our tmstrainingsolutions.com website. Following this, Keith gave a very, very important presentation on AGL safety. Keith, please.
Yes, I mean, AGL is an electrical system, and it comes under the umbrella for safe working under the high voltage safe working procedures. Then what I mean by high voltage safe working procedures, that at any electrical system that is above 1000 volts shall be deemed to require safety procedures. And here we are showing, and I will recognize Birmingham International Airport in the United Kingdom, and thank you for them for providing this little chart. It's a step-by-step process, and they have adopted 9 steps for actually working on an AGL system safely. Why? Because of high voltage safe working. In high voltage safe working, when we look at an AGL system, then we are operating traditionally in mostly around the world at 6.6 amps. 6 amps kill voltage burns, basically. You know, we've got to remember that. At 6.6 amps, for a human being, at 10 milliamps, you cannot let go. We've got 6.6 amps. Plus the power unit providing the electrical current, then is from a constant current regulator. That means the circuit is a constant current, not a constant voltage. And at constant current, the voltage varies according to the load. And the maximum size of a CCR internationally, in accordance with the IEC standards, is a 30 kVA. There are bigger ones in the marketplace, and Seward, who is with us, will have a lot of experience about higher voltages and different models of CCRs, especially in the FAA world. Now, when we're looking at CCRs, then the maximum voltage at 6.6 amp from a 30 kVA, if it were to be efficient, 100% efficient, if you use Ohm's law, then that would be 4,545 volts, nearly 5,000 volts. Now, potentially 5,000 volts will burn you and 6.6 amps will kill you. You get the two together and it's horrendous. You're dead, you know, and there has been death. Hence, safe working. The safe working procedures is a legal requirement, a legal requirement. And we had a long discussion about that, and anybody wants to contact us to revisit this subject, we're very happy to listen, you know, hear from you.
Okay. And we have a special guest, I think, for today's TMS Tuesday. That'll be Buddy, is it, Keith? Your dog?
Yes, yeah, I had a visitor at the door, so my little dog always joins in when there is a visitor at the door.
Right. Okay. So following that very, very important safety TMS Tuesday, we had a very well received presentation on LED lighting 20 years on, the lessons learned. It generated quite some discussion. These were some of the key issues. This is the highlight. This is just one of the slides we presented. Again, we have the full slide set on our tmstrainingsolutions.com website. The key thing about LEDs is that the LED itself will have a much longer life, but it's only good as the weakest point in that system. And so what we're seeing in particular is that we have some very long-lasting LEDs, but in particular, the lenses are not matching the life of the rest of the fixture. I mean, there are other issues, but I mean, the principal one is the lens life to me. And I'm seeing lots of situations where lenses are having to be replaced in life, which is unfortunate because clearly it would be good if the lens was matched the life of the fixture itself. And in particular, in very cold environments where they have snow and ice removal equipment, I've seen some very, very damaged lenses, and once the lens is replaced, then that can lead to other ongoing issues when there's a greater potential for water to get inside fittings, and that has a disastrous effect, of course, on the electronics. So so my message to manufacturers would be, please can we have longer lasting lenses in LED lights to match the rest of the equipment. We had a bit of feedback, didn't we, Keith, on I think some misunderstanding over our comments on halogen, where you know, look, we are independent. We don't favour LEDs or halogen. We can see the benefits of the benefits undoubtedly, and that LEDs will probably be the future for us. But the issue with halogen is that it is said that it will become increasingly difficult to get the lamps for halogen fixtures. Right now, there is not a problem. The halogen lights are still being made. They still work very well, and you can still get them. But there is the potential with environmental legislation and manufacturers no longer producing halogen lamps for them to become an issue. But right now it is not. Looking at other issues, I think the biggest thing I'm seeing at the moment, we're entering into the winter period in the UK, and for example, I tested an approach, a pretty new approach light system last week, and the elevated wing bars were completely frosted up. So the frost had formed on the lens itself, rendering the photometric performance unserviceable, non-compliant. It had to be scraped off to make them compliant. Now, not having heat in an LED light is an issue. Clearly, putting a heater in undoes the benefit of having LED lighting in the first place. So it is a challenge how to deal with that. And we're also seeing the buildup of water in front of lenses, in the slope in the front of the lens, where that can either freeze up, which makes the photometric performance completely non-compliant, or can just sit there because there's nothing to evaporate it in cold weather conditions. So that also renders the light ineffective in low visibility conditions, which of course when it's needed most. So these sorts of issues need to be addressed. And Keith, you've also got some comments on the electrical integration issues and the flashing and flickering of LEDs.
Yes, there has been some reported incidents associated with the LED, because the LED is an electrical component. It's a light emitting diode, and it needs a driver. And it has been reported that it is the driver failure which is creating a reduced life expectancy. That's all I'll call it, a reduced life expectancy. You know, so this consideration of 100,000 or 150,000 hours for an LED as an LED is probably correct, but you know, as a fitting, then of course the life expectancy is reduced because of the electronics. And as we also integrate further and further into the digital age and the surface movement guidance, the follow the green concept that exists with AceMegs, then of course then the different technologies involved associated with the CMMS and the smart lights that exist today, where the CMMS is integrated into the light fixture, an LED light fixture, then that has brought different challenges again. So are those challenges completely eliminated? I would suggest not at this time. But then hopefully manufacturers will come back and give us some up-to-date advice on that.
Yes, thank you, Keith.
Well,
So,
can I just
Tony,
about this icing thing, because it's been on my mind and I've commented on it for quite a long time. Tungsten halogen lamps are a great source of infrared at all times. And so they provide an inbuilt heater to varying degrees. And Robert's story of the recent measurement he did where the output had virtually been destroyed by an accumulation of ice. That's a real concern for approach lighting. If you had a very low temperature and once you can, and then you have a freezing fog and you go fog flying in it, the approach lighting will be selected as on, but it won't be producing anything like the beam spreads and intensities. If it's an LED light, as far as I can see, that ICAO specifies. With tungsten halogen, most airports I know, if they've had a period of non-operation, so that ice could have built up, they will switch their lighting on with their tungsten halogen for at least 15 minutes before the first movement of the day, and that generally clears the ice. So there's a technique there with which operationally you can put into effect and make it quite safe. Now that applies with PAPI, where at the very beginning we addressed the issue and said at that time all sources were tungsten halogen. You can do three things. You can do, like I said, with the approach lighting, make sure you switch it on for at least 15 minutes. But we did tests and trials of this to make sure it worked. Clear the lens by using the infrared of the beam at 100% for 15 minutes. You'll clear the ice. Alternatively, you can leave the PAPIs on all the time at a level where there's, as far as you can see, there's no light coming out of it, but there's still quite a lot of infrared, and that will keep the lens clear. We proved that as well. In other words, a 200-watt lamp, you're actually running at about 10 watts. And that's another method. And the third method is to put a heater inside the PAPI unit. Typically per lamp wear, again, about 20 watts we found was what you required. But this buildup of ice is important. And with the technology we've had remedial actions that we could take and procedures that didn't stand us into danger. But with what you were saying, Robert, I think there's an issue that's coming to the fore about LEDs and the build-up of ice.
Yes, yeah.
I think here that Seward maybe have, Seward under the FAA standards, then the approach lighting system is under the FAA directives, where the runway is under the airport responsibility. Is that the case? And how does the FAA look at approach lights in this respect?
Well, yeah, that is the case, Keith. And there is that division between the approach lighting system and the airport lights. The airport lights are typically maintained by the airport operator, the maintenance team there, and the approach light are done by an FAA employed people who specialize in that. And quite often, as we look at those systems, we'll find that the approach lighting system is better maintained than the airport system, because those people they're primarily looking at just those systems, and typically they have better output, better candela output, and meet the spec quicker than the ones on the airport and that are airport maintained. And I want to add just one other thing here about the tungsten halogen, and I don't think it was mentioned, but the tungsten halogen, the halogen process has to be active in order to keep the lens of the lamp, the envelope of the lamp, clear. Yeah. And it has to be operated up near the maximum intensity of the lamp. Like if you take a 6.6 amp, and we had examples of that out in San Francisco, they had the tungsten halogen lamps in their guard lights, in their in-pavement guard lights, and they typically didn't need to run them at high intensity. They would run them at low intensity. Well, they kept finding that their light output kept dropping so much that they found they were a short life lamp to them. Well, upon testing them, we find that they were running them at a low step most of the time. And when at a low step, the halogen process is not working properly, and you got the tungsten atoms building up on the lens of the bulb and diminishing the light output. And even one person even could notice that visually as he looked out that. And one key solution that they would use is they would bump their light output up to full intensity for a period of time, which would then reverse that and get that lens envelope cleared of the tungsten atoms, bring it back to the filament, and make things better. So operating tungsten halogen lamps at low intensity for periods of time is going to be a problem. Now, it's also true that when you do that, the tungsten vaporization rate on the filament is reduced. So the problem may not occur as rapidly, but we have to make sure that we keep that lamp envelope clear, and that requires operation of that lamp at higher intensities than normal, and that then may be required at a particular time. So that's another source of a problem on a tungsten halogen lamp, which I thought we we ought to be remembering. Go ahead.
Yeah, no.
Absolutely, Stuart. We picked this up in the UK back in the 70s when the tungsten halogen lamps first were introduced by the manufacturers as a wonderful replacement, longer life and so on. But we found in taxiway lighting, because of the large amount of time under running, they're actually getting shorter life, all the things you've highlighted. Exactly. But that's what happens when you change technology. You have to look at all these secondary effects, look around the benefits things, which everybody goes on about, and look and say, are there some gotchas in there that you haven't really picked up?
Yeah. Yes. Yeah. There's a lot to be wary of. But of course, and I hate to say this, but I'm going to. You can't manage what you don't measure. You've got to. These issues are identified because the performance of we measure the performance of the light output, and that will tell you that if there's an issue, and then you can investigate it and then address it, whatever it might be. But we've seen all of these effects that you've just been discussing. And just to mention one final thing on LEDs, Seward was involved with the FAA with studying the various methods for powering LEDs, because one of the issues, one of the drivers for LED technology is the lower energy cost. But we have still some way to go to optimize that. And that is work that I believe is still ongoing it is still ongoing in the industry, but there's more money to be saved. And Seward, you did some work on this, didn't you?
Yes. So we put in an all LED taxiway lighting system back in the early 2000s, and we found the system. What we did was change the 6.6 amps in the circuit. We dropped it down to a maximum of 2.8 amps. So reducing the current in the series loop resulted in a considerable reduction in energy losses in that number 8 conductor, which we normally use over here in the States. And so we looked at that, and then we ended up with a system that, from an energy standpoint, with the LED fixture and the proper size transformer, series circuit transformer, we got the energy cost down to about 5% on a typical airport, 5% at what it would have been under the incandescent system of old. And so we showed a lot of things happening there. It was after that the pulse wave modulation method of changing the intensity of the LED came into effect. We did not use that. We just changed the DC current level in the LED to change the brightness. And it was found that by doing that, we got outside the optimum current levels of the LED, which may have caused some color changes and some life issues. And so now we use the pulse wave modulation, which keeps the same current going through the lamp, through the LED all the time, and that optimizes the life. But to change everything over on the series circuit size, there's a lot of dollars invested in the infrastructure, and that's going to cost considerable dollars to save that. So we've maximized the savings that we get today. We still use 6.6 amps. We never did adopt the 2.8 amp as we tested with, but we still use the 6.6 amp. But with even that, we have about, I think it's about 30% of the energy used that we did previously.
Hello there. Are you there?
I'm here.
Oh, good,
I'm
good.
here.
Sorry, I lost you for a moment. Carry on.
I'm done basically
Okay,
there.
good. Right. Okay. Right. So thank you for that. I think so the message is to the industry, there's still some opportunity for savings, but of course it has to be balanced with the infrastructure cost. And then finally we talked about safety and compliance, competency and proficiency training, absolute vital ingredient. You can have the tools and the processes, but you've got to have competent and proficient people driving them. And Keith, this is your number one subject. So please update us with the developments there with ICAO this year.
Yeah, well, we've traditionally many years ago we looked at the whole element of training under the ICAO umbrella, and Seward, of course, you have been the equally amount of time under the FAA umbrella, and collectively we have merged very much together in this respect, and but of course the competency-based training is the guidelines now for which is coming out of ICAO, and it's basically imparting knowledge, having the skill to apply that knowledge, but of course the human factor element, the attitude of the personnel on the ground, there's also a factor. So CBTA is the way forward for our AGL trainings, and in all respects, no matter what your job function is, you're a designer, installation contractor, a maintenance contractor, a regulator, and the different technologies, controls, power, distribution, those three elements associated with the AGL as a system. So we have a structure now in place that we offer the industry based upon what we call CBTA and under the guidelines. And a lot of nations are now producing advisory circulars associated with CBTA requirements. And that is right away across from the pilot to the aircraft engineer, to the flight crew, to the ASEPs, the electronics personnel who look after the air traffic control systems of radar surveillance, communication, etc., right the way down to the airfield electricians, and it is a key issue. So that is what is on offer today, to be able to demonstrate and justify a competency decision for an individual, whatever their job function is. And the responsibility by the regulatory authorities internationally is placed upon the airport itself. They have to demonstrate competency of their personnel.
Yeah, thank you. And yeah, this is very important. This is and I like the structure that ICAO has brought into the process. Being good at your job is you know, you can be good at your job, but you need to be focused on continuous professional development, whether you're at wherever you are in the hierarchy of your career. So you know, so whether you're on the tools, or whether you're a manager, whether you're a designer, an installer, a regulator, there's a requirement to keep up to date, and to be able to demonstrate you've had the training and development commensurate with your position. So now we're just going to look at the key developments as we look forward to 2023. But as we do that, I'm just going to be setting up the prize quiz for you. For those of you that want to, feel up to it, if you have a smartphone handy, please go on to www.kahoot.it. So if you find a smartphone, go on to www.kahoot.it, and it will ask you for a PIN number, which I will present to you in just a second. So go to www.kahoot.it to win £100 for your nominated charity. So let me just stop sharing for a moment then. And Keith, well, no, Tony is going to be presenting the first couple of webinars, a very exciting prospect for 2023. Two webinars talking about the origins of the standards and recommended practices for airfield lighting. Tony, perhaps you could tell us a bit about that, please.
Yes, thank you, Robert. You asked me to do this. What I see is a presentation which is very much a sort of fireside chat from my experience looking across form. We can't look at all the AGL that is, if you like, in Annex 14, but some major components. In the first month, look at the approach and runway lighting together with PAPI. And in the second month, look at the ground side, in other words, the taxiway lighting and the signage. And to explain, first of all, what is the requirement? Where did the requirement come from? How was it established what was needed? What research was necessary to understand how that might be provided? And of course, then there's a dialogue with not just the researchers, which I am, but essentially you must have your engineers in the discussion and your end user, for goodness sake. You must involve the pilots. A dynamic discussion then, and a lot of testing over the years. But say for approach lighting, there's some fundamental principles bearing in mind. We're talking about a visual signaling system. So work was done about 70 years ago by people like Calvert to establish the fundamentals of how does a pilot get information from a pattern of lights. And that has a fundamental impact on the patterns that we have today, and the patterns are part of the specification. When you've got your patterns, then you can start putting your beam spreads on and so on. So I intend to sort of talk through in those areas, let's say, approach and runway lighting and PAPI in the first one, and the second one on the ground, the taxiways and the signs, and why we've got what we have got today. And if I dare say, I might suggest there's some things that could beneficially be changed or at least research done to see if there are improvements that could come for the future. Will that do?
Thank you, Tony. Yeah, very much looking forward to that. Now, if you could get your fingers on the buzzers, I will now launch our prize quiz. So if you can see there on the screen, hopefully the PIN number. So please enter the PIN 726846, 726846. And I can see you coming online there. So win some money for your favorite charity. 726846. I'll give you a few more minutes, another few seconds to launch on there.
I would like to say to everybody, Robert has banned us from participating on this.
Yeah, absolutely. Yes. We don't need any of your wisdom, knowledge and understanding. This is so good. So look, there's a number of you, there's already quite a number there. I will start the quiz. If you haven't managed to log on or otherwise, please do this for fun. You will see the answers and keep your score as you go through. So I'm starting the quiz now. Now, can I just explain that these are multiple choice? You will have a question at the top, and then you select the color for the answer, the right answer, and you'll see the 4 multiple choice answers. And you get more points the quicker you answer the question. So you have 20 seconds to answer the questions, but the quicker you are, the more points you get. And after each round, there are 10 questions after each round, or 11 questions after each round, we will get a leaderboard. So fingers on the buzzers, please. We're starting now. I can feel the excitement. So which airport surpassed Heathrow in 2014 to become the busiest airport in the world by international passenger traffic? Was it red, Dubai? Was it yellow, Atlanta? Was it blue, Istanbul? Was it green, Schiphol? Which airport was it? 5 seconds to go. 1. Good. So 9 of you got that correct. Dubai International. And now we will show the next. We'll go to the next question. The leader board, first of all, Ant-Man, well done. You were quickest with your finger. 855 out of a possible 1,000. Steve in second place, John in third place. Oh, is that John Laheath, I suspect, who won last time. So I think we should ban him. Come on, you're going to beat John. We can't have him win again, all the way from New Zealand. Though I have to say that is quite a feat of endurance to stay up for the quiz. So for the webinar, thank you if that is you, John. Thank you, John, whoever you are. In fact, okay. Next question. In 2016, Madeira Airport renamed itself after which famous locally born person? Was it Mourinho? Was it Eusebio? Was it Ronaldo? Or was it Vasco da Gama? So by what name is Madeira Airport known? Mourinho International Airport, Eusebio International Airport? Yes, 8 of you got that correct. It's Cristiano Ronaldo. It's renamed after him. So let's see what that does to the leaderboard. Steve on top there with 1,700 points. 1 point behind. John's creeping up the table there. Igor in third place, Dan followed by Fu. So well done, everybody. But we've got 9 more questions to go. Question 3. Which European city's airport is named after Wolfgang Amadeus Mozart? 5 seconds. 3, 2, 1, go. Right. So 9 of you guessed Vienna. That's not it. 2 of you got Salzburg, which is the correct answer. But was it John? Let's see. No, Steve and John didn't get the right answer on that one. And we've got some movement on the table. I think it's Andy moved up the table there. Andy, I should have guessed Andy from near Munich. So yes, you would. You should be ashamed if you got that one wrong. Well done, Andy. Next question. What is the IATA code for Los Angeles International Airport? LAX, LAW, LAI, HOL. Which one, what is the IATA code for Los Angeles International Airport? 5 seconds. 9 of you got that correct. So well done. Let's see what that does to the leaderboard. Oh, John, no stopping him. Right, followed by Steve, Ant-Man, Andy, and then Dan. So well done, boys. Come on, where's I hope there's some girls there somewhere. On to the next question. 5. Name the only UK airport in the UK other than Heathrow to operate 2 runways over 2,999. I'm not sure if it makes a difference to say 3 kilometers in length. 10 seconds. Is it Manchester? Is it Birmingham? Is it Cardiff? Or is it Edinburgh? And the answer is Manchester. So 10 of you got that correct. Let's look at the results then, the table. Steve and John neck and neck. Andy coming up very fast, followed by Dan and Paul not far behind. It's just effectively one question behind. Next question. Washington National Airport was renamed to honor which American president? Was it Bill Clinton, red, Ronald Reagan, blue, Barack Obama, not spelled correctly, yellow, or George Bush, green? So which president was it to have Washington National? Correct. Most of you got that correct. It was Ronald Reagan at which blue. So see what that does to the leaderboard. Oh, Steve was quicker with his finger on the buzzer there. John, you're getting slow in your old age. You must be tired. I know it's getting late. So and Andy there right up behind you. Paul moving up the table. Dan just behind. Next question. What is the better known name of Roissy Airport, Europe's Roissy Airport? Is it Le Bourget, Brigitte Bardot, Paris Charles de Gaulle, or Georges Pompidou Airport? The correct answer was Charles de Gaulle. Charles de Gaulle. Pretty much all the answers got guessed there. So let's see what difference that made to the leaderboard. Wow, Paul Fraser Benson goes leaping into the lead. Now we've got a battle, a 4-way battle right at the top there. Come on, Dan, you're not far. Only one question off. You could see what you can do when you get a toughie like that. Next question. John Wayne Airport is an international airport in which American state? Texas, California, Washington, Arizona. This is your chance. A bit of a tough question, this one. John Wayne Airport is an international airport in which American state? 4 of you correctly guessed it's California. So now let's see what that does to the leaderboard. Oh, Paul is there. John, followed by Steve. Andy just dropped back a question there, and Dan again. And on to the next question. In the 2000 film The Terminal, starring Tom Hanks, it's about a man who gets stuck in which international airport? Many of you will have heard about the actual man that got stuck in an airport who died very recently. So it's actually based on a true story. 6 seconds to go. Was it Trump, Bush, Kennedy, or Lincoln? It was Kennedy. 11 of you guessed that correct or knew that answer. And the leaderboard. Oh, you see, Paul Fraser Benison doesn't watch enough television. That tells us a lot, doesn't it, Paul? So yes, you can either live life or watch it. So yeah, congratulations on you, Paul. So John has gone ominously into the lead there by 300 points. We can't let him win again. Come on now, we've got one or two more questions. I'm not quite sure. We'll see what happens here. After the United States, which country in the world has the most airports? India, China, Brazil, or Russia? So this is quite interesting. Quite interesting, this one. I was wonder who knows that. Is it India, China, Brazil, or Russia has the most airports after USA? It is in fact Brazil. Now this could do something interesting to the leaderboard. Now let me see. Third place was Dan. Well done, Dan. You got that one right. Second place, Steve, 6,000 points. With 7,000 points, it was John. Well done. John is the winner again, reigning champion, I think now. That is John. I'm sure that's John Laheath.
Yeah.
Well done, John. If you could let us know a charity of your choice, we will make a donation to them on your behalf. And thank you all very much for participating in that. I'll show you now the full podium, I think, here. Do we have the full podium? So show you where you all came. So let me just have a quick look. Right, so fourth was Paul, fifth was Andy. And somewhere we'll publish the full results. I'm sure we can actually get those. But let's come back to the presentation. Thank you everyone for participating there. How many did you get, Tony?
8.
8, well done. And so all of you out there, Seward, how many did you get?
Actually, I didn't record it. I don't know how many I got. I got a few.
You got John Wayne, did you?
Yes.
I would hope so too. And Keith, how many did you get?
I'm not telling you, I'm embarrassed.
Well, look, thank you everyone. I hope you enjoyed that. Just a bit of levity at Christmas, just to kind of round things up. Just stick with the panel. Then we've got in the next year we're looking forward to. I said Tony is doing his presentations, explain to us the origins of the standards and the recommended practices, along with Keith and Seward, who are very well have a great deal of knowledge in these subjects. We'll be doing questions and answers. Understanding why things are as they are is very important to understanding them and interpreting them, which we all have to do in various ways, shapes, and forms in our job. So in January, we've got approach and runway lighting. And in February, we've got signs and PAPIs and taxiway lighting. Oh, no. January, we've got approach, runway, and PAPIs. And in February, we've got signs and taxiways. Then we'll be looking next year at visual aid standards. As Tony said, we're looking at continuous improvement. Technology is evolving, so standards need to evolve. And we'll be looking at that, and we're working with the visual aids committee to try to encourage those sorts of developments to move standards along as necessary. We're looking at LED lighting. What's coming next? We've raised a number of questions, but what's going to be done about them all? What are we going to do about snow and ice on LED visual aids? Because it's not just PAPIs, it's the signs, and it's not just the runway lights, it's the signs and the PAPIs, the approach lights, and even the stand lighting. we're looking at the AGL competency requirements and maintaining compliance. We will see, I'm sure we will see continuous development in those areas to ensuring that we keep up to date with all of the new technologies and standards as they come along. And one thing we'll be also looking at is the evolution of airport inspections and compliance from the regulatory side. We all know how important it is. The stronger the regulatory environment, the better the compliance we find looking internationally. And so it is important that the regulators, the inspectors, and the national and international authorities actually, create a very positive approach to proactive approach to inspecting and supporting airfields with their compliance environment, where they are challenged by cost constraints. And so there's always the challenge, well, about being able to afford the necessary investment in resources, both people, time and equipment and training, to be able to maintain their assets in a safe and compliant condition. But as a passenger, you would never, passengers expect that that's what you get. So in low visibility conditions, when they're needed most, they are actually performing. So we don't have a lot of questions today. I'm just looking to see, get some echo there. I'm looking to see there. I've just got one question here, because we're over time anyway, which I will ask, and that is GCAA released an MPA regarding new regulation related to onshore heliport and vertiport and offshore helideck as CAR-HVD. I'd appreciate your comments on it. Well, that's not an area of my expertise. If anyone can comment on that, please do. Otherwise, I would suggest we take that one offline.
Well, actually, Robert, what we can say is that when we're talking about heliports, then the ICAO issue guidelines and the standards and practices. Annex 14 Volume 1 is for principally aerodromes, which is really fixed wing aircraft, and the ICAO Annex 14 Volume 2 is for helicopter operations. And so then there is some additional documents that national and international authorities have written associated with that. And what is being referred to there with GCAA is that that is a national authority that have issued additional guidance to Annex 14 Volume 2.
Right.
Can I just say something about that, Robert?
Yes.
I hope it's interesting what I'm going to say. Keith's quite right. For many years, ICAO studiously avoided doing anything on helicopters. They said, we are concerned with international traffic. Helicopters aren't international traffic. They're pretty largely within the national organized country. It's up to that country to regulate it. They held that line for a long time until quite well into the 80s, when with the booming oil industry, places like the North Sea here, where oil rigs were being towed from the North Sea to the Caribbean to off China somewhere, and every time they moved, they had to be repainted and recut because it wasn't the helicopters becoming international. It was the heliports that were moving about, and there was a cry. What really got ICAO going was because ICAO wouldn't do it. The International Maritime Organization started to write standards and recommended practices, which of course was an invasion of territory issue, and ICAO at that point was goaded into actually writing Part 2 of Annex 14.
Right. So thank you for that, Tony. I noticed the question also related to vertiport. I think, am I correct in saying this is the new vertical takeoff and landing kind of taxi type aircraft that are being currently the next generation that are being developed at the moment.
Yes, yes.
I think it is. And these, so this is something we will see more and more of as you know, as these new technologies come, both in terms of this new generations of aircraft, and also the evolving aircraft, because we're going to see, you know, there, you know, all sorts of more environmentally friendly aircraft, hydrogen cell aircraft, for instance, are going to be, you know, potentially coming into commercial use in the not too distant future, hopefully, and those may well have differing requirements as a consequence that we need to consider in terms of our provision of visual aids, design, whether it's design, installation, maintenance, or inspection. So there's a lot going on. Life is not going to, 2023 is not going to be dull. So
I think, Robert, the vertiport, you're quite right. The technologies now are coming. As what often happens, the military are there first. I mean, that's where you're getting vertical takeoff and landing. I mean, it's been in the military for some time. You can see the potential spillover. They do have standards and recommended practices in the military. And I suggest, just as the military, in many ways, were the foundation of what we have in the civil world now at airports, the military were in the lead in many ways. And then they stopped being in the lead, and the civil world took that over. But there is quite a lot of knowledge, and there is quite a lot of implementation. I was involved in some very recent stuff there, and we had to design completely new light fittings and everything to comply.
yes, I could see, you know, and I can see these things becoming driverless pretty quickly as well, which would be quite interesting. You know, effectively people carrying drones. So Seward, has anything happening in FAA world on vertiports or next generation of aircraft?
Yes, we're just now beginning to see new draft standards coming out that cover this particular systems, and they're not out in full publication yet, but there are some drafts out, and you can see the renewed emphasis being put on that, or the emphasis being put on that in the future.
Right. Well, look, thank you for that, Seward. Well, look, I'd like to thank you, the panelists, in particular, for all the work you do tirelessly for you know, in terms of putting together these presentations, contributing to the presentations, and working and you know, being invaluable support to me personally. But also I'd like to thank on behalf of the audience, because we've maintained a very high audience figures throughout the year, who obviously must be getting value, had tremendous feedback literally from all over the world for these webinars. So they're garnering a great deal of interest, and so thank you guys for everything you do to make them happen. I'd like to thank you guys out there in the audience, because there'd be no point in doing these things if you weren't here, and we're sustained by your support and your interest in our very niche, but it's a very nice world to be part of, the aviation and airfield lighting in particular industry. So thank you for that. I'd like to thank my support colleagues, Felicity and Damon, back here at TMS, who have provided, who do all the background scurrying around. They do all the work, really. And and I'd like to wish you all a very happy holiday, happy Christmas, a happy time with your family, or whatever you're celebrating, whatever your religion. I wish you all the very, very best for 2023. And thank you for participating in our webinar. Thank you very much.
Thank you, Robert. I think we should say thank you to you as the guiding light of all of this, and providing this wonderful facility for the aviation world. And wish you a very happy Christmas holiday.
Thank you.
Thank you. Yeah.
I agree. Happy Christmas to you, and thank you for your leadership in this area.
Thanks. No, you're the guys that provide leadership. But anyway, thank you, everyone, and see you all in 2023 for the first when we're looking at the origins and standards of recommended practice of AGL, starting off with approach, runway lighting, and PAPI, presented by Mr. Tony Smith. Thank you. Happy Christmas. Happy holiday. Bye-bye.
Bye. Bye.